chapter 8.7, which is solving nonlinear inequalities. Solving nonlinear inequalities. So if we were asked to solve a system of nonlinear inequalities, there are a couple of things to remember. One is that then we use a dotted line equal to we use a solid line. Okay, so we have to graph two things here. We have to graph a circle and a straight line. So let's start with the circle. And remember we covered circles already. We know how to graph circles. We're going to graph x squared plus y squared is equal to 9. So the center is at 0, 0. And remember the square radius is equal to the square root of 9, which is equal to 3. So you would mark 3 points in each direction from 0 and solid line because it's less than or equal to, it has an equal sign. So solid line. And then you would graph your circle. Passing through those 4 points. Okay. So there's my circle, passes through all of the points. The center is at 0. And then we have x plus y equal to 3. This is also a solid line because it's less than or equal to solid line. And we graph this using intercepts. When x is equal to 0, y is equal to 3. And when y is equal to 0, x is equal to 3. Okay, so we mark 2 points at 3 and 3, and we graph this line. Let's see if this works. Sure does. Okay, now, as different from the other types of problem, this problem involves shading because this is saying that all of the value is less than 9 and all of the value is less than 3 solution. So we have to test values. We have 4 possible areas where the solution could be. It could be under the line but inside the circle. It could be over the line but inside the circle. It could be over the line but outside the circle. And it could be below the line but outside the circle. So only 4 possible areas. So you want to test values. We're going to select 0, 0 as the first point inside of the circle but below the line. Okay? And we're going to test it in the inequality. So testing it, we have 0 squared plus 0 squared is less than 9. So 0 is less than 9, which is true. Okay, then you have to test it in the second equation. 0 plus 0 is less than or equal to 3. So 0 is less than or equal to 3, which is also true. So this is telling us immediately that the shading for this circle is in this area where the point 0, 0 is located. Now, if one of these were false, then we would have to go and and try another part of the circle. Okay, so that tells us where the shading is. The shaded portion is the solution. The shaded portion is the solution. If you were doing this in my lab, then we would have to go ahead. I'm going to just show you real quickly how to do this. So I would make my circle graph first, center, and then 3 points out with a solid line. Okay, make sure you select the solid line, and then the straight line solid also. Now by default it's a solid line, okay, and you put your straight line passing through +3 and +3. And then you have to figure out that the shading is inside of this part where the 0, 0 is. So you use the paint bucket, tip it into that part, and save it. Okay, and check your answer. So most of the time you'll get to the correct answer. Just make sure that you're using the graphing tools and that you're paying attention to whether the graph is solid, whether the lines are solid or dotted. Okay. Let's look at one other problem, perhaps. So let me clear this similar question. I'm going to copy this graph because I like this graph, and I'm going to do another example for you. That one with another example with a circle and a straight line. Yeah. Okay, so here's a similar type question we have to solve. And by the way, your calculator is not going to be much help with a question like this. Okay, solve. The system given is y is less than, sorry, my bad. X squared plus y squared is greater than 36, and x plus y is greater than or equal to 6. Okay, so for the circle, center 0, 0, the radius is at 6. So mark 6 all around and use your calculator, your tool in my lab to make your circle. Yeah, not a lot of work here. I have this tool that I'm still learning to use here. Okay, so there's my circle. Now, can you tell me what's wrong? This is a dash line because it's greater than, so it's a dotted line. And I made a solid line, so I'm going to go with my eraser and make this into a dash line, okay? Line is dashed. All right, then the second system, this is for x squared plus y squared is equal to 36. The second system is x plus y is equal to 6. So when x is equal to 0, y is equal to 6. When y is equal to 0, x is equal to 6. And we plot those points. We put a line through those 2 points. Oop, not the tool I wanted. 6 and 6. And this one's a solid line, since it's greater than or equal to. Now, remember what I told you, that there's 4 possible places where this graph could have a solution. Let's try 0, 0 first. Test 0, 0. First equation, we have 0 squared plus 0 squared is greater than 36. So obviously this is false, because 0 is not greater than 36. So next we're going to try a point above the line but inside of the circle. Let's say at that point right there, test say 3 and 4. Okay, so 3 squared plus 4 squared is greater than 36. 9 plus 16 is greater than 36, and that is false. So now let's go outside of the circle and test the points. Say you got a lot of points out here. How about 7 and 7 right there? Okay, test 7 and 7. That's 7 squared plus 7 squared is greater than 36. And this is true. Okay, 49 plus 49 is greater than 36. So make sure you test in the second equation as well. 7 plus 7 is greater than or equal to 6, which is also true. So this is telling us that the shading is outside of the circle and above the line right there. Outside of the circle and above the line. Now I want to also show you how to graph systems that are not circles. For example, let's take y is greater than x squared minus 9 and y is less than or equal to x minus 3. So one is a parabola and one is a straight line. So y is equal to x squared minus 9, dotted line, since we have a greater than. Okay, this is vertex. It's the square function down 9 places, so vertex at 0 and negative 9. Mark that point, 0 and negative 9. And then we pick a point perhaps to the left and to the right. You can immediately see that when x is equal to 3, y is equal to 3 squared minus 9, which is 0. So we have positive 3 and negative 3. Make sure that you sketch a dashed line for this because it's greater than, not greater than or equal to. Okay, and the second one is y is less than or equal to. So we're going to say this is less than or equal to, it's a solid line, y is equal to x minus 3. When x is equal to 0, y is equal to negative 3. When y is equal to 0, x is equal to positive 3. So we have intersections at negative 3 and positive 3. Solid line. Okay, since we're dealing with less than or equal to. So solid line through these points. And we want to now test values. So we've got 4 possible places where this could be shaded. It could be shaded under the line but inside of the parabola. It could be shaded above the line and inside the parabola. It could be shaded below the line and outside of the parabola. And it could be shaded above the line and outside of the parabola. So we're going to start with the easiest points. First, let's start with 0, 0. So test 0, 0 at this point here. So testing in the first equation, we have 0 is greater than 0 squared minus 9. That means 0 is greater than negative 9, which is true. And then if we test in the second equation, 0 is less than 0 minus 3. Okay, so 0 is less than negative 3. 0 is not less than a negative number, so this is false. Okay, so clearly the shading is not in this area. So now we want to go and test a point, say inside of the circle but below the line. Let's go ahead and try that. Inside of the parabola but below the line. Let's say we got that through. Now let's go ahead and test in the second equation when y is equal to negative 4. So negative 4 is less than or equal to 0 minus 3. Negative 4 is less than or equal to negative 3, which is also true. So this is confirming that the shading is in this section right here, below the line but inside of the parabola. Okay, I went ahead and did this question in my lab and noticed the dotted line and so on. Okay. All right, only 2 questions in the section. I actually did 3 examples for you, but there are only two problems in the section, one with the circle and one with the parabola. Go ahead and close this.